This video is made to prepare you for the part of the SAT that will ask you a question regarding system of equations. Specifically, we are going to deal with system of linear equation, okay? Whenever we deal with system of linear equation, we are basically having two lines on the same system, in the same xy plane. Now, if we have two lines in the same system of equation, there are various cases that can happen. In fact, we can have the two lines intersecting each other, like in this case. And in this case, they have one point in common. That's not the only case that we can run into. In fact, we can also have a case of infinitely many solution where the two lines are on top of each other. So in this case, we see only one line just because the two lines are sharing the same spot. But we can have also a no solution system of equation where the two lines are parallel. So they're going in the same direction, but they are separated with each other. Now, let's analyze each of these cases individually, starting with the main cases, the cases that most probably you're going to solve most of the time during the exam, which is the case of intersecting line. When we have two intersecting lines, what's happening is that they share one point, and the question most probably is going to ask you to find the coordinate of the point that they're sharing, okay? They can ask you to find the satisfy or the repair. They can ask you to find the solution of the system, the coordinate, the intersecting point. They're always asking for the coordinate, x, y, of that point. How do we do that? Well, there are two main methods. One is called substitution, one is called elimination. Let's take a look at both of them, starting with substitution. Now, this is a very simple question. The question says, which order pair x and y satisfy the system of equations shown above? Although they are not asking straight up, they are asking about the coordinate x and y of the point in common between these two lines. Now, as we can see here, we don't have anymore the graph like we saw before here, but we need to figure out how to find the point without graphing. On the SAT, it's not required for us to do graphing. Also, we want to save time, so we don't want to graph. How do we do it? Well, by doing the substitution method, one thing that we can do is converting both equations in slope-intercept format. So that's going to be our first step. Now, on our first equation, that is already in slope-intercept format, y equal 2x plus 4. While on our second one, we need to do some switcheroo, and that will be y equal x plus 1. What I did is just switching the y in one position, in one side, and the number 1 in the other side. Once we do that, the next step will be the one of placing them equal to each other. Why? Before we were talking about this situation right here, right? We were talking about the situation where they share a point. At that point, that's the only point where the coordinate x and y of the two lines are going to be the same. So at that point, the y from the first equation will be equal to the y of the second equation, as well as the x and the x. Because of that, I can say, instead of y equal to y, I can say 2x plus 4 is equal to x plus 1. That's it. This first part represents this y. The second part represents this other y. The two equations now, they are combined and they don't lose their meaning. But the advantage is that now we have an equation with only one variable, x, and we can solve for it. Let's do it. We will move the x on the left side, we will move the 4 in the right side, and we will get 2x minus x equal 1 minus 4. That means that x is equal to -3. That's it. We already found the x coordinate. To find the y coordinate, what do? We take the value of -3 and we plug in one of these two equations. Which equation? Well, it's up to us. For example, we could choose the second one and we will say y equal -3 plus 1. That means that y here is -2. So our coordinates are simply -3 for x, -2 for y. And that's why our answer in this case is answer B. Now, during the SAT, we want to save time. We could have saved time here by being aware of the possible answer. In fact, the only possible option that gives us coordinate x -3 was B. So we could have stopped the proceeding for solving this equation at this stage. We would have saved 15 seconds maybe. That's fine. That's what we want to do during the exam, okay? The other exercise with that allows us to solve with a system of equation is the elimination method. Now, the elimination method is slightly different, doesn't request us to convert the equation in a slope-intercept format, and that can be helpful when we have fraction, like in this case. And on top of it, is very helpful when we are looking just one coordinate, like it is in this gradient question. This question says, if the order pair x, y satisfy the system of equations shown above, what is the value of x? So here we just need to find one coordinate. Again, we don't need the slope-intercept format. I'm going to leave the equation in this format, but what I'm going to do is to eliminate the fraction. How can I eliminate the fraction? By just using one of the property of equality. In fact, I can find the least common denominator of the first equation, which is just 5. Both fractions have as a denominator 5, so it's going to be 5. And I'm going to multiply both sides by 5. If I multiply an equation both sides by the same value, the equation stays the same. But by doing that, now I'm eliminating the fraction here, and now my new equation will look like this. It will be 2x minus y equal 98 divided by 5 is going to be 490. This is question number 32. So in this case, we will be allowed to use the calculator if you want. In the second equation, we will do the same proceeding. We need to find the least common denominator between 7 and 14. In this case, it's going to be 14. We will multiply both sides by 14. By doing that, what we will get will be, in this case, a multiplication of 2 here, but here will just go away. So here we will have 2 by 2, which is going to give us 4x plus y equal 55 multiplied by 14 is going to be 770. So now I have my two equations in standard form, but they're without the fraction. Since I'm using the elimination method, this one allows me either to add or subtract the two equations together. In this case, I will choose to add them because my main goal since the very beginning was to eliminate one variable. And here, that's what happened with the y value. In fact, -y plus y will give us 0. And so our equation now will look like this. 6x equal 1,260. Remember, the question was asking to find just x, and that's exactly what we have in our new equation. Let's solve for x. We solve for x, now we will have 1,260 divided by 6. That means that our values for x will be 210. That is a gradient answer. That's what we would place inside the gradient. For any system of equation that have a coordinate in common, we can choose the system to use. For this question, we can choose to do either the substitution or the elimination, whatever is more convenient to us, okay? Here the question says, if x and y is the solution to the system of equation above, what is the value of x? Now, as I said before, since we are just looking for x, we could just use the elimination method, right? To use the elimination method, what we do is basically trying to make one variable equal to the one below, but with the opposite sign. And since we're looking for x, our goal is to make the two variable y with equal sign but different, with the equal number but different sign. Since the first equation is has a coefficient for y that is 4, and the second one has a coefficient of y that is 3, the two numbers that we can use to make them equal are the number 3 here, we can multiply by 3 in both sides here, and 4 at the bottom. Actually, on the top, I'm going to multiply by -3. So by doing that, I obtain on the equation in blue 9x minus 12y equal -16. On the one below, it will be 24x plus 12y equal 60. We obtained what we wanted. Same number, opposite sign for y. The y will go away and it will go to 0. Because again, we are adding in this case. Notice though, that by doing that, also this value will go to 0. What does it mean? Well, although this one is going to be 33x, it doesn't matter. That's going to be just 0. That's the final answer here, okay? Let's take a look at the substitution method. If it is true that both methods can be used, the same one, we should get 0 also in this case, right? So in here, what I'm going to do is taking the equations, right? And convert them in slope-intercept format. That means that for the first one, I will move the -3x in the other side, and now we will have 4y equal 3x plus 20, and then divided everything by 4, or multiply by the reciprocal of 4, which is 1/4. If you don't know what a reciprocal is, wait a few minutes and I'll explain it to you. By doing that, now we isolate our y, and our first equation will look like this. Y equal 3/4x plus 20 divided by 4, which is 5. We do the same proceeding for the second one, and that will be moving the 6x in the other side will give us -6. And then we will divide both sides by 3. Once we do that, what we will get y equal -2, because -6 divided by 3 is going to be -2x plus 15 divided by 3 is 5. Hey, again, Same steps as before. We need to say y equal to y. That means that we are going to have 3 over 4x equal negative 2. 3 over 4x plus 5 equal negative 2x plus 5. Since plus 5 and plus 5 are in both sides, that means that they will go away. So as before, what we have left are just the x values. Even if we move the negative 2x in the other side, what we get is going to be negative 3 over 4x plus 2x equal to 0. Final result, even for this case, is giving us that x is equal to 0. So, as I wanted to show, both method works for a system of equation. I hope this one clarify everything regarding solving a system of equation with one point in common. But now let's focus a little bit with the two special cases that we have with system of equation, which are the case where the lines are on top of each other. When the two lines are on top of each other, they are sharing each point. That means that the two lines are coinciding lines. And then we have the case of parallel lines, where we have no solution in that case. As I mentioned before, during the SAT, we don't want a graph. If a question is asking us to recognize if we have a case of infinitely solution or no solution, we are not going to be there and start drawing lines and trying to understand. That's not what we want to do. We want to look at the equations that are given. Specifically, what we want to do is whatever equation they give us, converting them again in a slope-intercept format, where my m represent the slope, meaning the inclination of the line, the stiffness of the line. Sometimes this one is also called gradient, but that's usually called gradient when we have a higher degree for x. And then we have b, or also called c, q, wherever. That is going to be the y-intercept, the point where our lines will intercept with the y-axis. Okay, if the two equations that we converted in slope-intercept format have same slope and same y-intercept, so basically they are the same, that's a case of infinitely many solutions. But if they have same slope, different y-intercept, like in this case, we have a case of no solution. That's how we find out if we are running into these two cases. Let's take a look at some exercises, starting with the case of infinitely many solution. Usually a question on the SAT that is regarding infinitely many solution or no solution is going to ask you about that specific case, like in this question. Another ingredients, here they're asking, for what value of k will the system of equation above have infinitely many solutions? Here, the question straight up is asking for the case of infinitely many solution. We know that if it is a case of infinitely many solution, the two equations in the format of slope-intercept will be the same. So that's what we're going to do. We are going to convert those equations in the slope-intercept format. The second one is already in that format. We just need to reorganize it. For the first one, we need to do some switcheroo. We will move the 6x in the other side, and it's going to be negative 6x, and then we'll divide both sides by k. And by doing that, we'll get y equal negative 6 over kx plus 3 over k. So, in this specific case, what do? We need to find k. There is no actual calculation with the method that we are doing to find k, but we can use plug and chug, plugging in. Let's try to find a number that, for example, by dividing 3, we'll get to 1, and by dividing negative 6, we'll get to negative 2. In this case, it's pretty easy, because what number will divide 3 to make it 1? That's going to be 3. And since the 3 works also for the -6, because -6 divided by 3 will give us -2, then k must be 3, because it will make the two equations equal. However, there might be cases of infinitely many solutions where there are involved decimal, maybe fraction, where just plugging in the value might be hard to find the value of k, or to find out how to make it and how to make them equal. So to clarify this passage, we need to discuss the main concept of equality between equations. In fact, if we have two equations, the format doesn't matter. Standard form, slope-intercept form, doesn't matter. But if we have two equations, and these two equations are the same, meaning equations that are consistent and dependent, and they have infinitely many solutions, then the ratio of their coefficients must be the same. Let me explain. A ratio is a division. Ratio is a comparison of two numbers by a division. So it's a division. A coefficient is the number next to the variable. So these values right here. On the previous one, we are talking about the 6, the -2, and those kind of things. The numbers that don't have any variable next to it, they are called constant. So basically, these theorem is telling us that if we divide the coefficient of x, the result must be equal to the division of the coefficient of y as well as the division of the constants, so that the two equations are the same. As we can see, these theorem allow us to use use the equation in standard form. We don't need to do the modification on the slope-intercept form. And by using this method, we have a method of calculating the k. In fact, let's go over the same problems. Now, though, we will keep the equation as they are. The first one is going to be 6x plus ky equal to 3. Now, the second one, I'm going to put it in the same order. So I'm going to move the -2x in the other side, and I have 2x. Y stay as it is, and that's 1. Now, if I divide the two values, the two coefficients next to x, those must be equal to the two values next to y, the two coefficients, and they must be equal to the constant. As you can see, the first fraction actually can be simplified in 3/1, and that's the same as the third ratio, as the third division, as the third fraction. That means that we are going to the concept of infinitely many solution. To find the value of k, what we have to do is taking two ratios and put them equal to each other. When we put two ratios equal to each other, we are just creating another equation. And we can solve for k in this case. This one will be very easy, and it will tell us k is equal to 3. That's it. Nothing else to do. So here you have two methods to solve the same question. Question is asking to find a system of infinitely many solutions. One is very quick and very intuitive. One is a little bit longer, but will give you the sure answer. It's up to you to use the one that you prefer. Let's take a look at this question. Here we have a system. In the system, there are two values that we don't know, a and b. And here they say, in the system of equation above, a and b are constant. If the system has infinitely many solutions, what is the value of a over b? Now, I can use both methods that we saw before to solve this question. But in this case, I'm going to use the first one, the one that converts the two equations in slope-intercept format. And I'm doing it for one reason. I know that by doing that with the very first equation, I will get A over B. In fact, I will move the AX in the other side and I get BY equal negative A X plus 12, right? And then I will divide both sides by B and I will get Y equal negative A over B X plus 12 B. 12 over B, forgive me. At the moment, our focus is just on A over B, right? Then let's see what's going on the one below. Because if I do the same work on the one below, I get Y equal negative Q over 8 plus 60 over 8. Now, Q over 8 can be simplified in 1 over 4, but that's not the point. The point is that, as you can see, here we found A over B. A over B is not negative because that's not what they're asking. A over B is just Q over 8 or 1 over 4. The official answer will be this one because because we'll try always to give it the simplest form of a fraction. Okay? Let's talk about parallel lines now, where we have no solution. Now, when we have no solution, that means that we have same slope, different y-intercept. We got this one. In a question like this one, where they ask which of the following system of equation has no solution, the first thing we want to do is actually, again, convert it in slope-intercept format. That's what we have to do. Here we don't have a second method at the moment. So I'm gonna start with A, and I'm gonna do this conversion. And the first equation is the following. I'm gonna move the X in the other side. So now I'm gonna have 1 over 3y equal negative 1 over 5x plus 1. And now I want to isolate my y. That means that I need to multiply by 3. I need to multiply by the reciprocal. If I multiply by the reciprocal, this means that the value on x to y will go away. So I isolated successfully my y. And now I have y equal negative 3 over 5x plus 3. I do the same proceeding with the second one, moving the 3x in the other side, and I will get negative 5y equal negative 3x plus 15. And now, multiply by the reciprocal of negative 5 will be 1 over negative 5, both sides. By doing that, by negative 5, and now I got y equal negative by negative is positive 3 over 5x minus 10 divided by 5, 3. So we did our job. It took us 1 minute. Maybe without talking, you would do it in 30 seconds. And we finally did the conversion. Now we need to ask ourselves, is this the case of no solution? To be the case of no solution, we need to have same slope, different y-intercept. In this case, although the numbers are the same, they have opposite sign. Because of that, the first requirement is not fulfilled. That's not the case of no solution. That's not our answer. Here, though, there is a problem. If we keep following this proceeding also for B and C and D, that will take us forever. They will take us more than the minute and a half we have usually for question. So, is there another method? The answer is yes. And this depends on the pattern of the sign. So, in this case, we have the case of no solution just because of the sign. But we knew since the very beginning that the two signs of the slope were going to be different because the pattern of the values of x and y were different from the first and the second equation. In fact, on the first equation, x and y are both positive, while in the second one is positive and one is negative. Because of that, we knew that we were going to end up with two different signs. Now, this method of checking is way faster, and we can apply that one also to our next case, the case B. And look, the case B is like the case A. So without even doing the conversion, we know that they are going to end up having two different slopes. So as A is wrong, also B is wrong. And here we are left with C and D. C and D have the same pattern, but that's already successful for us because now we have only two options. We have a 50-50 situation. That means that we need to do this proceeding only once. If we got it right, then that's the case of no solution. If we got it wrong, then that's not the case of no solution. So let's try to convert C, for example. If we convert C, the first equation will be now y equal 3 over 2x plus 7 over 2. The second one will be y equal 3 over 2x minus 9. Here, we finally got the same slope. But we don't stop right here because now we need to check also the y-intercept. And in this case, the y-intercept is different. Because of that, this is the answer. Okay? Very well. I want to make you notice something else though. Yes, we finished the answer. We answered this question, we can move on. But look at possible answer D. Because possible answer D has a certain pattern as well. In fact, if we just take the coefficient, we will get 1 over 2 as the ratio of the coefficient of x, 2 over -4 for the y, and 1 over -2 for the constant. This is a case of infinitely many solutions. All the ratios are the same. They are a case of infinitely many solutions, so they couldn't be our possible answer. So you see, this question has multiple layers for to be answered with. The last one that we did is perfect. If you also notice that this is a case of infinitely many solution, even better. Let's talk about this question. In the xy plane above, line L is parallel to line K. So these two lines are parallel. What is the value of P? Here they're asking about the value of P. How can we find that? So, since the two lines are parallel, they have same slope, right? Can we find the slope of these two lines? Absolutely, we can. Because we have a formula to find the slope. Displacement on y over displacement on x. For the line L, for example, the slope will be 2 minus 0 over 0 minus -5. That means that the slope is 2 over 5. Since we find the slope of the line of L, we also find the slope of line K. What does it mean that? Well, that means that we already have one step to find the line for K. What we need to find now is B. But do we need to find B? No, it's right here, B. B is going to be -4 because B is the y-intercept. That's it. Now, how can we find P? P is an x-intercept. In fact, we have y to be equal to 0 here. So we solve for y equal to 0. And now we will move the negative 4 in the other side, and we will get 4 equal 2 over 5x. To isolate our x and then find it, we will multiply by the reciprocal, which is going to be 5 over 2 in both sides. 5 over 2 will go away here, and here we get x equal 4 divided by 2 here is going to be just 1 and 2. 5 multiplied by 2 is 10. 10 is our answer. I hope that all these clarified the concept of system of equation, infinite domain solution, and no solution. But we got to talk about one more thing, which is the case of perpendicular lines. Because you see, here we have two lines that are crossing each other. They have a point in common, but that's not the important part here, because here the two lines have an angle of 90 degrees. They form angle of 90 degrees. That means that they are perpendicular. Well, we have perpendicular line whenever the slope is negative reciprocal. What does it mean? I've been talking about reciprocal, and so far I think you got it for the amount of time I use it. But let me explain quickly. A reciprocal is the flip version of a number. For example, if I have 5 over 2, the reciprocal will be 2 over 5. If I have 4, the reciprocal will be 1 over 4. In general, the multiplication of the original number with its reciprocal would be 1. Now, to be perpendicular, the slope needs to be negative reciprocal, meaning that when we multiply them, here the result would be -1. And that's a method of realizing when we have perpendicular line. We multiply the two slope, and the result is -1, we have perpendicular line. Like in this case, here we have a orange line with a slope of 3, then the blue line with the slope of -1 over 3. The multiplication of 2 will give us -1. Then we know that those two are perpendicular. In this question, they ask, the graph of line K is shown in the xy plane above. Which of the following is the equation of a line that is perpendicular to the line K? To find out the perpendicular line of these, we first need to find the slope of this line. Now, we say that the slope is displacement on y over displacement on x. We usually find it by starting from the y-intercept and then follow the pattern. In this case, we go 1 step to the right and 2 steps below. That means that my slope is going to be 1 to the left, so denominator equal to 1, -2 to the top, to the numerator, because we went 2 units below. So the slope is just -2. What's the reciprocal, the negative reciprocal of -2? Well, in that case, will be +1 over 2. The only equation here that has as a slope 1 over 2 is C. That's our answer. And with this one, I think I covered everything you need to know about system of equation. Let me know if you have any question. You can comment, you can text me if you have my phone number. And I'll see you next time. It's a pleasure. Enjoy your day. Bye.